All the things you see around you are made of these tiny little things called atoms. A 70 kilogram human is made out of 7 billion atoms. A nuclear power plant shoots tiny particles at kilograms of fuel with big and heavy atoms, splitting them to generate lots of heat. It's like in snooker when a cue ball hits the triangular pack. The cue ball is the particle being shot, the triangular pack is the big atom, which splits into pieces. And the heat produced is like the sound you hear. However, these big atoms are also unstable or radioactive. This means that they shoot out tiny particles and light with very high energy, which can severely damage the bodies of living things. With cooling, nuclear power plants can use the heavy atoms safely to get heat energy, which can then be converted into electric energy. However, in 2011, when an earthquake and tsunami hit the Fukushima nuclear power plant, its cooling system failed. The fuel heated up so much that it melted the things all around it. And remember how the fuel is unstable and dangerous? When the Fukushima nuclear power plant melted, fuel leaked into the air and the sea around the power plant, leading to mass evacuations in the vicinity. Atoms have a nucleus which contain protons and neutrons. If you take a sufficiently heavy atom like uranium and shoot a neutron at its nucleus splits, releasing heat energy. This reaction, fission, is what allows nuclear power plants to generate heat, with many fuel rods containing pellets of radioactive material undergoing fission and heating up. This reaction boils water into steam, which is then used to power a turbine, which then generates electricity. Maintaining the consistent generation of electricity are control rods, which are like traffic lights for fission reaction. They can be inserted between fuel rods to varying extents to slow or speed up the reaction to adjust the electricity generated. And making sure the reactor does not overheat are water cooling systems. In 2011, there was an earthquake in Japan, followed by a tsunami, all in the same day. The earthquake triggered the fuel rods to be deliberately inserted to protect the Fukushima nuclear reactors, stopping the generation of electricity. However, cooling was still required as a fuel rod still produces heat on its own. The electricity to power the water cooling system thus had to switch to diesel generators. The tsunami which followed killed the diesel generators, causing the nuclear fuel to overheat and melt, and eventually causing radioactive particles to leak into the atmosphere and the sea. Fission reactions can produce neutrons, which can start more fission reactions, which can produce more neutrons, and on and on and on. This is a nuclear chain reaction. In a nuclear reactor, the chain reactions are controlled such that it produces lots of heat energy at a steady rate, while avoiding an explosion like that of fission bombs. Full insertion of control rods would prevent neutrons from one fuel rod from reaching another fuel rod, slowing down the chain reactions such that no electricity is generated. This is what happened after the earthquake in the Fukushima nuclear reactors. However, neutrons from the nucleus can still collide with the nuclei in the same fuel rod, which still produces heat. As such, cooling is still required. When the backup diesel generators for the cooling systems fail, the residual heat slowly caused all the water in the reactors to boil away. Why is this bad? Apart from turning into steam and powering turbines, water also slows down neutrons produced from fission, to the point that they cannot split a nucleus. Without water, more neutrons are fast enough to split nuclei in a fission reaction, causing the fuel and the structure around it to heat up and melt. This high heat also caused the cladding around the fuel rods to rapidly react with steam, forming hydrogen gas. This gas buildup caused the reactors to lose its airtightness and caused explosions in 3 out of 4 affected reactor units, leading to the leak of radioactive isotopes into the atmosphere and the sea.